having me. Appreciate the beautiful Bald Head Island going out from the towboat ride. Kind of cold on that one, but so I have a really short presentation, just to give you an update on the wastewater treatment plant. Have any questions, glad to take those along the way. So I think last year we talked about this. We focused really on the wastewater treatment plant itself, but I want to point out that as part of this project, also be upgrading Timber Creek. Timber Creek is your primary pump station that collects all the wastewater on the site and delivers it to the treatment plant. So it's part of it. I just wanted to point out that that's also included in the project scope as well. So some discussion points today. I want to talk a little bit about capacity, just review where we're at on that. We have completed preliminary design, moving forward on the final design. I want to update you on the cost estimates where we're at today, and also an overview of the schedule. Just a quick overview, your plant and water plant and your building all located on the same spot, which is really good. It's convenient. It's also efficient. Sometimes that presents a challenge from being able to expand. Fortunately, we are able to expand on the existing site. We don't need to acquire any additional property. So while it is a bit of a tight site, it does work for us really well. And of course, your treatment plant's there is a square. So some specifics on the plant itself. Currently it's at 300,000 gallons per day. That's the rated capacity. Now the plant has the ability to pass 400,000 gallons per day hydraulically. We can move that much water through it, but it's limited in its ability to meet the limits. And that's primarily related to air and blower capacity in the plant, which is just maxed out at this point. And I'll talk a little bit about that as we go through this, but so currently you're at 300,000. A few years ago, we went through a process to evaluate what the build out looked like on the island, and we came up with about 650,000 gallons per day. So that's our target for expanding the plant is 650. Unfortunately, and I do believe we talked about this last year as well, a few years ago, we also climbed the hill and went ahead and got the disposal capacity. And I always say, we can treat it. Give me whatever wastewater you got. We can find a way to treat it. The challenge is disposing of it, especially here on the coast. We have a lot of challenges with finding places to dispose of from an environmental standpoint. Point discharges in the rivers are just about impossible to get. So wells can be a challenge at times. Fortunately, we were able to identify places to dispose of the treated wastewater, which includes the infiltration basins, which are located on the golf course. And also the golf course itself is doing reviews. So your 650 is taking care of it, which allows us just to really concentrate on the plant itself. And the plant is a sequential batch reactor plant. And basically what that is, I always describe this to people in if you think about it, there's two different types of plants. There's a flow, continuous flow plant, and then there's a batch plant. If you think about a plant, it's like a house, and a house has many rooms. And we take the flow and we run it through every room in the house, and every room has a different condition. So it treats the wastewater differently as it goes to the house. Batch reactor, we have one room, put the wastewater in, and we change the conditions in that room. And the advantages of that really here are it's very flexible with high and low flow. And perfect for the island because you have some really low, your flow is probably extremely low right now. We all know July 4th just goes through the roof. So a lot of flexibility in that batch process and handling those flows. And if we started from scratch right now to build a brand new plant, I think we'd still stick with the SPR process. And if you recall, last year we decided on what's called an activated granular sludge process. And it's still an SPR, it's still a biological process. It just uses a different type of organism that creates a little bit of biomass, allows us to do more treatment in a smaller footprint, which is good. It saves on footprint, which is construction costs. It's also a little bit less expensive to operate. So 30% design is based on that, and we're proceeding forward on the final design based on that process. And this is just an overview to give you an idea how the plant itself works. So everything you see in green is what we call forward flow. That's the wastewater comes in, it gets treated, and it goes out and ultimately is disposed. The two brown, there's actually three banks here, the digesters in brown. As you're going through the treatment process, you're removing organics from the wastewater. Those organics also have to be treated separately. And typically what you're trying to do is reduce those organics. That's also a biological process, and the microorganisms are working on that activated or that sludge. It breaks them down, reduces the volume, and ultimately it's either landfill or applied to a spray field or something like that. So very important part of the process. In blue, there's the blowers. I mentioned earlier, the blowers are a challenge at the current plant, and it's kind of hard to tell from there, but that blower room is maxed out. We replaced the blowers a few years ago. We can't get anything else in there. Going above 300,000, that blower is a limiting factor. So we're obviously going to be addressing that in the expansion. But so generally, if you look where it says pre-EQ, that's an equalization basin. Wastewater comes into the equalization basin. That's basically a holding tank, or it goes to one of the three SBRs, which is the batch reactor process. The reason we need that EQ is because we got to be able to regulate the flow going into the batch process. Some are filling, some are draining, some are treating. So that EQ basically allows us to normalize that flow in each one of the basins. Once it leaves the basins, it goes to a post EQ, which is also a holding tank, and it's doing the same thing, except the next step and the last step is up in the upper right, is disinfection. This plant uses ultraviolet UV disinfection. So again, we want a smooth flow going through that UV process. So the post EQ is also very important in that process. That's a little bit about how the batch process works, and how we manage flow through the plant. And again, the digester is there to break down all the organics that are removed from that flow. Probably more you want to know. Any questions on that? So what does the improvements look like? And as I mentioned, using the AGS process, the activated grain sludge, allows us to do more in a smaller footprint. Prior to this, we were actually looking at having to build some additional basins to be able to meet your flow. But switching to this process allows us to reuse the same basins and do the same treatment, more treatment in the same footprint. So the three boxes you see here on the left are actually existing batch reactor basins. We're going to be upgrading those. The blower room, which is really too small, we're going to convert that to a chemical room. Not a lot of chemicals in a wastewater plant. I think we're doing pH and alum, JP. There's not a heavy chemical dosing or anything in wastewater treatment. A couple of old digesters, we're going to convert those to some equalization and buffering tanks as part of the process. Right above that, it says upgrade digester one. We're going to maintain that digester, but we're going to do some upgrades to it to handle the additional flow. And ultimately, yellow is the ultraviolet system. I think that has been in place at least 20 years, 20 plus years. So it's kind of reached the end of its useful life, not only from, it needs to be upgraded for capacity, but also it's kind of at the end of what you can really do with it. So that'll also be upgraded. The new facilities are highlighted in the three new facilities are highlighted in the bold red boxes. We have two additional digesters. As you increase flow, you create more organic waste, so you have to have additional digestion. And then the blue is a mechanical / blower room. As I mentioned, that's the limiting factor. So we're going to have a whole separate room dedicated to blowers to be able to do that. And that's pretty common. Most plants, they do have dedicated blower facilities. And the reason for that, for the air, is that, as we're trying to maintain these microorganisms. They're carbon creatures just like you and I. They need food, water, and air. And if you can't produce enough air, you can't maintain that microorganism population. So of all that stuff, blowers are really, really important. So we felt like a dedicated room made the most sense based on the flows we got today. This is, as I mentioned, we were at 30%, and this is just a 30% engineering drawing overlaid on an aerial photo. About here, this is kind of the break between the old. These are the new facilities that I was just talking about. We're trying to do common wall as much as possible because that saves us money. But we are progressing that 30% design. I mentioned the Timber Creek pump station, and this may be a little difficult to see. This on the left is just the existing station. And on the right is a preliminary plan. We thought about rehabbing this station, but we realized it was a capacity challenge, and it's really not in the best shape. So from a cost effectiveness standpoint, it made the most sense just to replace that station. So this area here you see is kind of dashed with new wet well pump station. So I just want to mention that is part of the project when we talk about it. So you have a complete upgrade, not only from your inflow pump station all the way through your plant, if you have full disposal capacity. Cost. So in May of 2023, we had an estimate of $30.2 million. Last year in February, we had bumped that up to 33.3, basically just looking at inflation in the market. And as we sit here today, probably a little over 34 million. So what I attempted to do was basically just add some basic inflation to this, just as a guideline to see what it looks like. My crystal ball is as cloudy and as cracked as everybody else's. Historical inflation for the past 40 years is about 3.2, 3.3%. I've just kind of done a straight line application of that. Assuming in 26 or 27, if that's when you actually take this to bid, that's likely the number you can see, somewhere between 36 and $37 million to build a plant. And I will say that it is difficult to estimate, really difficult to estimate construction right now in the market we're in, but it's even more difficult to estimate construction on the island. Remember, years ago, we did a project and it came in twice our estimate. We had a real learning process and we started talking to contractors and they're like, it doesn't, something that takes me 2 hours with a dump truck takes me 8 hours over here. Because they got to ride the ferry back and forth. We got staff people, that sort of thing. So we have, to the extent we can, have tried to build this into the estimate to understand the challenges with working on the island. So that is also part of this estimate, to the extent we can. Any questions on that? I think again, it's just an update of where we're at. Nothing significantly has changed last year other than just updating from an inflationary.
Just a curiosity question. Sequencing the construction, when you have a juggling act, obviously we're going to be flushing toilets every day, whether you're, how does this work? Just in, without going into it a whole lot, I assume that you can keep some of the pieces going, and if it's a slow season, you're building new, and as new things get built out, they have to be done by the time the high season comes.
With the SBRs, that you have 3 basins, you have a lot of flexibility. You can do one at a time, you use the other 2. You have multiple digesters, you can use those multiple basins. So you have a lot of flexibility just in how the plant is being constructed now. And also, I think scheduling wise, what needs to be done in the off season versus what needs to be done in peak. And you're right, we probably limit the work in the peak season contractor. But I think, as compared to like
things, so like I'm looking at this, you're converting digester to sludge buffer tanks as a critical component. Sludge buffer tanks, and I'm looking at, well, I got to move my blower room is growing, and the blower room is critical, so I got to have the new blower room ready before I get rid of the old one.
So we typically, as part of our design, create what's called an MOPO, a MOPO, which is a maintenance of plant operation. So every design will have a laid out, you shall do this first, this can't start till this is done. And the blower would be like the very first thing. The digesters, we probably build the blowers and digesters first. That allows us to take everything else online, and then we do the SGRs one by one.
Okay, great, thanks.
Thinking through that still a little bit, but something along those lines. And my last slide is just to talk about the schedule. Schedule's been improved. Last time we talked, we weren't sure which direction we were going with Aquarita, or we were having to add additional like basins, which would extend the design and permitting process. We've been able to shorten both of those a little bit. We have completed preliminary design. We're estimating this fall, around September, to be able to have an actual permit set, submit that set to the state, get all the comments in. Make those comments probably by the end of the year, maybe first of 26, and then have you ready to go to bid in the I guess the fall, first quarter of 2026. Should you choose to do that. Now, depending on how your development is occurring, you may want to delay that. But I think the important thing is they'll have that permit in hand, and you've already got your disposal in hand. So that checks a really big box for us. We also estimated about 20 months for construction. I think last time we were talking, we thought it may be more like 30 months, but based on the changes we made in the current design concept, we believe that 18 to 20 months is definitely doable now. So that I think is positive. And kind of tying back to my estimate of what I think the estimate may look like if you do bid this in 26, so you may be looking at $35 to $37 million range, assuming inflation stays relatively flat or normal. Of course, any kind of world event could disrupt something and cause things to go through the roof, but to the extent you might estimate those So total duration of about 35 months as we stand here today, have enough operations.
Before we went to lunch, we had a conversation about financing and grants. And it was suggested that if we could break the project into parts, we could apply for different kinds of grants and financing. And I don't know if that's built into this. Can it be broken into parts?
Break it into, I'm sorry, I meant to say.
Broken into segments, if you will, so that we could apply separately for different financing and grant options.
I don't think there's a way to do this in pieces and parts. I may be misunderstanding you, but JP, I don't have any comments on that. In other words, to get the full plant, you have to have all the pieces and parts built. I think where you may have some advantages, as I said, having your permit in place, having the plans ready to go, being shovel ready, often puts you in line for some grant money there. So
Maybe we need to talk this through a little bit more.
and maybe if I misunderstand it, maybe.
Yeah,
I'm thinking that they were talking about like having a grant for the rest of his work before construction. That's what I was thinking.
yeah, there's, but also, when you're looking at, delays in getting equipment, it's, so you got blowers, you know, and construction isn't gonna happen until this date. Can we be buying the blowers now? And we got a grant for doing that. I mean, you know, can we get stuff stored on site or on island? So when the actual construction starts, so many of the components are bought already here and purchased in phases or as components.
Yeah, we actually have talked about that. I think that's a valid point, to consider pre-purchasing items depending on what that is. I think we want to get a little further in design and understand what those are.
Got it.
If there's grant money available to do that up front, then absolutely would make sense to go after that. Maybe that's what. So it can be done in pieces and parts from that standpoint, but the plan itself has to be. The advantages of pre-purchase is, you know, you solidify the price, don't pay a contractor's markup for things, but then you also own that equipment. You don't risk it.
Got it.
It's damaged.
I understand that.
But we do that anytime. There's several projects we're doing right now with all the equipment up front, and it's actually saving quite a bit of money.
Because Peter touched on this a little bit. So the materials that you need to do this, how long does it take?
Yes, anything electrical, that's always the engineer's answer, right? It depends. Anything electrical, especially like generators, can take a year to 15 months. This generator, I think we've got a generator on this, it may be a little smaller, maybe in an 8 to 12 month range. If you have specialized equipment, sometimes that is an 8 to 12 month range. Even basic equipment, 4 to 6 months. So there's a whole slew of equipment here. And
Yeah,
different
yeah.
ones have different.
That's all factored into your
Yes.
35-month estimate. Okay.
Yeah, Tony, one that, fear. So, the process we've been going through, the design, the different stages, you know, we've been keeping to a schedule that's you know, we're forced to follow. Worst case scenario, we're ready to go now. Now we do need the capacity upgrade, and the numbers came in as like, boy, we thought they were going to be 36. They're 54. Is there any kind of a plan B? Or are it's like, it's 54, it's 54, I'm sorry.
This is 54, I'm sorry.
Well, 54 million as opposed to 32. You know, I'm saying it's like when it comes down to, you know, you can project, well, this is what I think it's going to cost. But, you know, I'm also in construction industry. It's like, yeah, this is what we thought it was going to cost. I'm sorry, we just had this huge leap and this is what it really is going to cost. And I hate to tell you, you don't have any choice. You got to build it anyhow. And my question is there ever a plan B?
That's a tough question. Most funding agencies historically understand that you have an estimate and sometimes it comes in a little under. They have funding reserves and they make that difference. That's part of it. But if you have some huge difference between like 30 and 50 million, that would probably be a big ask. My personal opinion is there's a lot of opportunity and been a lot of success in state appropriations in the past few years. And asking for that money, and you can ask for it in multiple cycles.
Yeah, my question isn't about the money itself as opposed to physical plans. Like, you know what, we're gonna do half the blowers, we're gonna do half of this, we're gonna do. Or are we at that? It's like, I'm sorry, it's too late for that.
No, well, we'd probably have to do a modified design, but there would be a version of this that you could take it, say, to 50 instead of 300.
Okay.
So you could definitely modify the design. There would be some time associated with that. Essentially value engineering it back to a capacity that.
Right.
Yeah, I'm sorry, I understand what you're saying now.
Yeah,
There's
yeah.
Definitely an intermediate step if needed.
Okay. Good to
You
know.
had in your numbers chart, you had a 30% thereabouts contingency. Right? Estimated contingency, that's 6,980,000, estimated contingency down there. See it?
Second to last line.
Yes.
Right? So that, 6.9 of 23.2 is about 30%.
Correct.
That's a pretty big contingency number. Is that where you bake in the bald head factor, or is the bald head factor figured in all those other numbers? In both?
So the reason that we try to put the ball head in the estimates, at this stage, 15, 20, 25%, we try to stay in a higher contingency for exactly what you said. We don't know
Right.
what the market's gonna be. And historically in an engineering design, as we move through like 50%, 60%, 90%, we would lower the contingency. And
Right.
when I get ready to go to bid, I would probably have it in at about a 10%.
Okay.
I think that's reasonable. But at this stage, because we're estimating a lot of this stuff, but we haven't designed it.
That's
So,
Mhm.
got it with a boat.
Right.
This is just sort of a repeat of what we talked about. So next steps, we're gonna finish design and permits in hand by the end of the year. If you're ready to bid in March, should make sure it will be ready. I did also, as we've been talking, monitor market conditions, and I think it's a good point to keep thinking about pre-purchase of units. As we get to a point, we're communicating with JP on this, and we start identifying things that make sense. JP, I think you're putting in your screen now, so.
Yeah, we've already
It is.
purchased the screen, that's going in this week, starting this week.
Yeah. So, and we've been doing that with a number of other clients, identifying those specific things that you really may want to think about buying these now.
Got it. Okay.
Was it?
Hey, Tony, thanks so much.
Thanks, Alex. Good job.
You'll get your badge later by being done on time and all that.
I swear, but I got.
Yeah.